Welcome to lecture 4. In this lecture, we will understand the risk structure of interest rates. So let's get started. All right. So to give you a preview of this lecture, the first thing that we will study is that we will examine the sources and causes of fluctuations in interest rates relative to one another. Okay. And the second key point that we will cover in this lecture is that we look at the various factors that can explain these fluctuations. Okay. All right. What's the key learning objective? Well, the key learning objective of this lecture is that you should be able to identify and explain the three key factors that explain the risk structure of interest rates. All right. So to begin with, we start with this graph, which is extremely important in motivating the rest of our analysis on the risk structure of interest rates. All right. And in this graph, you can see that we are showing interest rates on various securities. We are showing interest rates on US government long-term bonds, which is the dark green line. We are showing the interest rates on US state and local government bonds, which are also known as municipal bonds. And then we are showing interest rates on corporate AAA rated bonds in red. And we are showing corporate BAA rated bonds in blue. So essentially, we are showing the evolution of interest rates from 1919 to 2014 on four different asset classes. The first is the US government long-term bonds. The second is the state and local government municipal bonds. The third is the corporate AAA rated bonds. And the fourth is corporate BAA rated bonds. And it's important to note that all four asset classes that we are showing here have the same term to maturity. Okay, they are all long-term bonds. Where they differ is in their risk characteristic. Okay, so the US government long-term bonds are often referred to as risk-free or default-free bonds because there is very little risk that the US government will actually default on the interest payment or the principal payment on the loan that they take from the lenders. Now, municipal bonds are relatively riskier than the completely risk-free US government bonds. Okay, even more riskier are corporate AAA rated bonds, while corporate BAA rated bonds have even greater risk characteristic in them. Okay, so what, according to you, are the 3 or 4 key points that come out of this graph? Well, the first and the obvious thing that we can see is that interest rates on different categories of bonds differ from one another in any given year, correct? So in any given year, let's say 1970s, the interest rate on US government bonds is very different from interest rate on corporate BAA bonds, correct? So in any given year, the interest rate on these 4 different asset classes is different, correct? What's the second key point to note? Well, the second key point to note is that the interest rates on municipal bonds were higher than those on US government bonds in the late 1930s, but lower thereafter. So you can see that in this graph that the light green line, which is the interest rate on municipal bonds, was almost always higher than the dark green line, which represents the interest rate on US government bonds up till late 1930s. But thereafter, the interest rate on municipal bonds has almost always been lower than the interest rate on US government bonds, even though, as we have discussed earlier, municipal bonds are riskier than US government bonds, correct? Now, the third key point to note is that the spread or the difference between the interest rate on any 2 different asset classes varies over time. Again, we can go back and see that the difference between, say, for example, corporate BAA rated bonds and the municipal bonds has not been constant across all these years. It has been changing over time, right? Finally, it is worth noting that the spread between the interest rates on BAA corporate bonds and the US government bonds was very large during 1930 to 1933. We can see that very clearly in this graph, where the difference between the blue line and the dark green line is especially pronounced during the years 1930 and 1933. Now, what was so special about this period that the spread between the corporate bonds and US government bonds was so large? Well, these were the years of the Great Depression in the US, where a lot of businesses were going bankrupt, and as a result, many borrowers defaulted on the debt that they had taken from the lenders. As a consequence, interest rates on riskier assets shot up tremendously. Okay? So the objective of this lecture is to discuss the key factors that can help us understand this graph better. In other words, what we really want to understand is what are the factors that can explain why interest rates on different bonds with same maturity differ from each other so greatly. Okay? And in summary, the answer to that question is that bonds with the same maturity can have different interest rates due to different default risk, liquidity, and tax consideration. Okay? So let us understand first of all what do we mean by default risk and how that can lead to bonds with same maturities to have different interest rates. Okay? Alright, so to begin with, how do we define default risk? Well, default risk is a risk or the probability that the issuer of the bond fails to make the promised coupon or face value payments to the lender. Alright? In that regard, as we discussed earlier, US Treasury bonds are considered to be risk-free or default-free. And why is that? Well, that is because the government can always raise taxes to pay for its debt, correct? And an associated concept that comes with the concept of default risk is the concept of risk premium. What is risk premium? Well, risk premium is the spread between the interest rates on bonds which have default risk as opposed to the interest rate on same maturity of treasury bonds. Okay, so if for example we are talking about a BBB rated corporate bond of, say for example, 5 years to maturity, which has an interest rate of 10%, while on the other hand, if a US government bond of again 5 years to maturity has an interest rate of, say for example, 5%, then we say that the risk premium on BBB rated corporate bond is 5. Right? Because the interest rate on corporate bonds is 5% higher than the interest rate on government bonds, even though the term to maturity for both bonds is the same. Okay? Now here we are showing how exactly an increase in default risk increases interest rate on corporate bonds. Okay? So to begin with, assume there are two kinds of bond markets. On the left hand side, we are talking about a corporate bond market where we have demand and supply curves for corporate bonds. While on the right hand side, we have the US government bond market, where again we have the respective demand and supply curves for the US government bonds. Okay? And to begin with, we are assuming that the demand and supply for both corporate and US government bonds are such that the price of corporate bonds, which is P1C, is equal to the price of treasury bonds, which is P1T. Okay, so at this point we are assuming that corporate bonds are also riskless. Okay, now what happens if there is an increase in default risk on corporate bonds? Well, we know from the asset market approach that demand for an asset is negatively related to its risk relative to other assets, correct? So as the default risk on corporate bonds increase, the demand for corporate bonds decrease and the demand curve shifts from D1C to D2C. At the same time, the demand for treasury bonds increase. Why? Because treasury bonds are now relatively safer than corporate bonds. And as a result, the demand curve for treasury bonds shifts from D1T to D2T. Correct? What's the consequence of all this? Well, the consequence is that the price on corporate bonds decrease from P1C to P2C, and the price on treasury bonds increase from P1T to P2T. Okay? And since we know that prices and interest rates are negatively related to each other, we can also note that the new interest rate on corporate bonds, I2C, is actually greater than the new interest rate on treasury bonds, I2T. Okay? So this exercise hence explains how riskier corporate bonds usually have higher interest rate than risk-free government securities. Okay? Now you may ask, how do we know the risk characteristic of a particular bond that is being traded in the market? Well, it is precisely for this reason that we have rating agencies like Moody's and Standard & Poor and Fitch that rate all different kinds of bonds that are traded in the market based on the characteristics of the borrower. And as you can see from this graph, AAA rated bonds are regarded as very safe investments, while as you go down the table, the risk characteristic of the investment increases. So if you reach C or D rated bonds, these are highly speculative or even junk bonds, okay? What it really means is that the risk component of C or D rated bonds is very high, and it's very likely that these bonds will actually default. In other words, it's very likely that a borrower who is rated C or D by these rating agencies will default on the interest payment or the par value of the loan, or both, okay? Now, another key factor that can cause two different bonds with same date of maturity to have different rate of interest is liquidity. Now, what do we mean by liquidity? Well, as we may have discussed in earlier lectures, liquidity is the relative ease with which an asset can be converted into cash. Now, the two key factors that determine how liquid an asset is first of all the cost of selling a bond. That is the transaction cost that is associated in selling a particular bond. And it is also worth understanding that liquidity of an asset is also determined by the number of buyers and sellers we have in that particular asset class, okay? So if you have a lot of buyers and a lot of sellers, it's very easy to sell a particular asset at a very low transaction cost. On the other hand, if you have invested in a particular asset where you do not have a lot of buyers and sellers, then you may have a lot of difficulty in selling that particular asset. You may either have to wait a long time, or you may have to incur large transaction costs. Hence, if we have two bonds with the same date of maturity, let's say bond A and bond B, but bond A is more liquid than bond B, then with the same analysis that we have done earlier, we can see that the more liquid of the two assets, which is bond A, will have a higher price than bond B, and as a consequence, the interest rate on bond A will be lower than bond B, okay? In other words, the interest rate on less liquid assets have a kind of liquidity premium associated with them, okay? Finally, we discuss how income tax consideration can also lead to two different assets with same date of maturity to have different rate of interests, okay? And the best example here is to compare US municipal bonds with US Treasury bonds. So on the left hand side, we have a market of municipal bonds where we have the respective demand and supply curves for municipal bonds. And on the right hand side, we have the market for US Treasury bonds where we have the demand and supply curve for US Treasury bonds. And to begin with, we are assuming that the risk characteristic of both these type of bonds is the same. The liquidity characteristic of both these type of bonds is also the same. And we are also assuming that returns from either of these investments is taxed at a uniform rate, okay? Hence, as a consequence, the equilibrium price of municipal bonds, which is P1M, is the same as the price of treasury bonds, which is P1T, okay? Now, what happens if there is a change in tax laws that dictate that returns on municipal bonds will not be taxed while returns on treasury bonds will continue to be taxed? What happens then? Well, as you can guess, your effective post-tax return on municipal bonds become higher than your return on treasury bonds. As a consequence, the demand for municipal bonds increasing the price of municipal bonds from P1M to P2M. On the other hand, the return on treasury bonds is now lower relative to municipal bonds, correct? And as we know from the asset market approach, this will decrease the demand for treasury bonds. As a consequence, the equilibrium price of treasury bonds decreases from P1T to P2T. And again, since prices and interest rates are negatively related to each other, this explains why interest rates on municipal bonds have been lower than the interest rates on treasury bonds for most part of the last 70 years in the US, okay? Hence, by now, we understand that risk, liquidity, and tax considerations are the key factors that dictate the risk structure of interest rates, correct? But before we end this discussion, it's worth understanding the concept of interest rate risk. Now, what is interest rate risk? Well, it's important to understand that even highly liquid, default-free bonds can be considered as risky if they are not held to maturity due to fluctuations in bond price. And that is what we mean by interest rate risk. That is, changes in interest rates I can lead to bond price volatility and consequently lead to capital losses, which increases as the term to maturity increases. And that is the reason longer term bonds have a concept of term premium associated with them, and we will discuss more about it in lecture 4.2. But for now, it is worth recalling lecture 2.3 that also illustrated the concept of interest rate risk very well. So if you recall this table, we discussed how when interest rate changes from 10% to 20%, the holder of the bond incurs capital losses and how these capital losses increase with the term to maturity, correct? And this is exactly what we mean by interest rate risk, the bond price volatility due to changes in interest rates for bonds that are not held to maturity. All right, so that is it for this discussion. In lecture 4.2, we will discuss the term structure of interest rates. Thank you.